Hello there, fifth graders. Ms. Jagodnik here again with another math lesson in our review section of the year. So this is a review of what we learned way back in lesson 8.6, which was about finding the area of a rectangle. But you've known how to find the area of a rectangle for a long time. It's simply length times width. The added twist to this lesson was that now the length and the width aren't whole numbers. So you're not just doing regular multiplication like your times tables. You have to also incorporate your strategies for multiplying by fractions or by mixed numbers to make it a little more complicated. So we're going to take a look at a few problems today, and they are not in your book. You do not need to follow along anywhere. It's just some examples of how you would do this kind of problem. And then you could look back at the pages in your book and work on your practice buddy on your own. Okay, so this is pages 487 and 492 if you did want to look back at the pages in your book and how we did it back then. But again, these problems are just not in the book. They're just made up for you to see some examples. We're going to be doing the examples as models to remind you of what that fraction times fraction model looks like, because that was one of the trickier ones we worked with this year. And also the multiplication so that you have two different ways to think about it. So here's our first example. I have a rectangle and its length is 1/2 a unit and its width is 1/3 a unit, and I want to find the area. This is how I would set up my model. Okay. Instead of labeling my open array here with a number of units this way and a number of units this way and drawing squares on the side, I want to think of this square here as one whole. And I want to be able to divide it up into fractions so that I can see exactly how much of it would be the area of a rectangle with these dimensions. So the first thing I notice is that my length is 1/2 of a unit. So if I think of this as being one whole, this is 1 unit, then I'm going to divide it in half and shade half. This is my length, 1/2 a unit. My width is 1/3 of a unit. So now I'm going in the other direction. I'm going to divide my rectangle into thirds, and I'm going to shade 1/3. Okay, so there's my rectangle dimensions. I have 1/2 by 1/3. So if I take a look at this model, I want to look at what parts are shaded in both colors. Remember we did this back in class? Here is the section that has orange and green. So that is the section that I colored for 1/3 and 1/2, because remember we are finding 1/2 times 1/3. So we're finding like 1/2 of 1/3 or 1/3 of 1/2. So this is the area of what I come up with when I do 1/2 times 1/3. Now, I see that it's only one box shaded in. And I see that there are 6 equal parts in this unit. So that means that how many are shaded in both colors? 1 out of 6. Okay. And because we're talking about area, it would be units squared or square units. So when I do 1/3 times 1/2, this model shows that 1/6 is where they intersect, and I color it in both colors. So that means the area of a 1/2 unit by 1/3 unit rectangle is 1/6 unit squared. Let me see if that works out with the multiplication as well. If I'm going to do length times width and I'm doing 1/2 times 1/3 using our fraction strategies, remember that means we are doing the top and we are doing the bottom. Numerators get multiplied, denominators get multiplied. So for the numerator, I have 1 times 1 equals 1, and for the denominator, I have 2 times 3 equals 6. So that actually matches very nicely with what my model showed me. So 1/6 unit squared, is the area of this rectangle. Now, let's go on to a couple more and see if it works out the same. Here, I get a little more complicated. You notice my model is a little different because I saw that this is an improper fraction, which means it is more than one whole unit big. So I need 2 units to show that. But I'm going to do the same thing. I'm going to first look at the denominator. There are 5 as the denominator. That means I'm talking about fifths. But remember, when I'm cutting up a whole, that means that there are 5 equal parts in one unit, not in both of these. So I'm going to cut this up into 1, 2, 3, 5. That's fifths. Now I'm going to cut this one up into fifths because I know that these 5 fifths are not going to be enough. I need to shade in 8 fifths, so I need 2 to do that. So now I'm going to shade in 1, 2, 3, 4, 5, 6, 7, 8. That is a length of 8 fifths, or 1 and 3 fifths. I shaded in the whole thing here, and then 3 fifths of that one. Now my width is not an improper fraction, it's a regular old fraction, but I'm going to cut across both of them because I still have to deal with this shaded part over here too. So my width is fourths, which means I'm going to cut everything into 4 equal parts. And I'm going to shade 3 of them. So these top 3 bars are going to get shaded in green. This 4th here is left alone. So now I need to figure out how many of these parts have been shaded in both colors. So I'm talking about this section here, because this is orange but not green, this is green but not orange. These are what is both. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. It looks like I have 24 pieces shaded in. Now, what's my denominator? My denominator, remember, is how many pieces did I cut 1 into? 1 whole. So I cut 1 whole into 5 rows of 4, which is 20. So my area is 24 20ths. Now, if I make that into simplest form, I can take out 1 whole and I have 4 20ths left over. Oh, but wait, I see both of those are multiples of 4. So my simplest form answer would be 1 and 1/5 units squared. Okay, let's see if the numbers bear that out. If I do 8 fifths times 3 fourths, my answer would be 24 20ths. So again, I would put that into simplest form, but obviously it's the same answer. My simplest form would come out the same too. So that's a nice check to be, because this is a complicated, weird type of model that we don't use too much. It is a nice check to be able to use our number strategies and calculate and make sure it's the right answer. Okay, moving on to the next one. Again, I noticed that this was an improper fraction, so I drew 2 units here so that I would have enough space to shade everything. I am cutting each one in 2/3. Okay, so 3 equal parts here, 3 equal parts here, but I need to shade 4/3 so that first unit square wouldn't be enough. I'm going to shade 4 of them. Now for the width, I'm doing tenths. So again, I'm going to cut all the way across. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. And I need to shade 7 of them. So these bottom 3 are going to stay blank. Okay, and I'm going to shade all the way across Okay, now I've run out of orange, so these parts aren't gonna count for the area, but I'm still gonna shade it properly. Okay, so there we go. There's my whole section that's been double shaded, this section here. These 7 rows and these 4/3. Those have been shaded in both colors. Okay. So I made 7 rows times 4, that's 28 little squares I've shaded, and I made 10 rows and I divided in thirds this way, so it's 28 out of 30. Okay, before we put it in simplest form, let's just make sure that our numbers work as well. 4/3 times 7/10 is 28 over 30. Perfect. So if I want to put it in simplest form, I notice they're both even. So I know I can divide by 2 over 2. So that gives me 28 divided by 2 is 14. 30 divided by 2 is 15. So 14/15 units squared. Okay. Last one here I wanted to show you is a little bit different because instead of calling it a rectangle, they called it a square, which I know is a type of rectangle and the formula remains the same. I can use length times width, but I know the length and the width are going to be the same because that's what a square is. It has all equal sides. So it tells me it's a square. It only needs to tell me one number because I know all of the sides are going to be the same. So it tells me that each side is 5/4. So again, I had to make a lot of boxes here, you notice, which is why I really wanted you to see this one, because I have an improper fraction, but now I have an improper fraction for the length and the width. So when I go ahead and cut this into fourths, 1, 2, 3, 4, and I want to shade 5 of them, I'm going to need this here too. So now they're all in fourths, and I can shade 5/4. But when I go in the other direction, I also am going to need more than one because if I cut everything into fourths here, I need to go into this box too in order to shade 5 of them. So I'm going to shade my 4/4 here, but also 1 in the next one. Okay, so there's my 5/4 here. So when I look at what's been double shaded, it's 5/4 in this direction and 5/4 in this direction. There we go. That's my area. So I have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5 by 5 means I've colored in 25 squares altogether, and it's 4 by 4 in one of these unit blocks, so it's 25 out of 16. So that would be 1 and 9/16 in simplest form. Does that make sense? Is it in simplest form? Yes, because the only thing I can divide 9 by is 3, and 3 does not go into 16. Okay, so let's see with the numbers if it makes sense. 5/4 times 5/4 is going to give me 25 over 16, which is the same thing. I would put it in simplest form and it would end up being the same. And of course, oh, now I have a unit, feet, so I want to say it's in square feet. Okay? Okay, so that's how you find the area of a rectangle if the dimensions, the length and the width, are in fractions. You can use a model. I know it looks a little complicated, but if you're asked to use a model or to match a model to an equation, you should know what this type of model looks like. So that's just a little reminder that these are the kind of models that you would use graph paper, or you would draw it out yourself, and you would make sure that if it's an improper fraction, you have more than one unit to work with, and you divide it in one direction for length and the other direction for width, shaded in properly, and then you should be able to count the number of squares that were shaded in both directions in order to figure out what the area of that shape is. But because it's so complicated and it looks difficult, that's always a good idea to check by doing your fraction multiplication, because now that you've reviewed that and you remember it's just multiply the top, multiply the bottom, that's a quick, easy strategy to use, and then you can check if something went wrong with your model or if you did it properly until you get used to doing them again. So again, this is lesson 8.6, pages 487 to 492 in your book. You have the video assigned to you. You have the student edition assigned to you if you want to look back at those and refresh your memory even more. And then, of course, you have your practice buddy so that you can work on some independent practice. And I will see you again in a couple of days.